For billions of years, Earth has been a delicate, self-regulating system. This miraculous blue planet, the only known home to life in the vastness of the universe, owes its existence to a finely tuned balance of forces. The interplay between the Earth's atmosphere, magnetic field, tectonic activity, and life itself creates the conditions that sustain us. But what happens when this equilibrium is disrupted? When the mechanisms that protect and nurture us falter? The answer is both a sobering warning and a call to action, for the balance that sustains Earth is not guaranteed to last forever. Our planet's story begins in chaos. 4.5 billion years ago, Earth emerged from the violent birth of the solar system, a molten sphere battered by collisions with asteroids and comets. Slowly, over millions of years, the planet cooled, forming a thin crust and the early oceans. Life, fragile and resilient, began to take hold. Through eons, Earth stabilized, with its magnetic field shielding it from deadly solar winds and its atmosphere trapping the heat necessary for life to flourish. But these systems, so integral to our survival, are not immutable. They are dynamic, prone to shifts that could have catastrophic consequences. Earth's magnetic field is one of its most critical features. Generated by the churning of molten iron in the planet's outer core, this invisible shield protects us from the sun's harmful radiation. Without it, life on the surface would be impossible. Yet, the magnetic field is not constant. It weakens and strengthens, and at times, in Earth's history, it is even reversed. Such geomagnetic reversals, where the north and south poles swap places, have occurred irregularly, the last one happening 780,000 years ago. Scientists have observed that the magnetic field is weakening today, a potential precursor to another reversal. What would this mean for humanity? During a magnetic field reversal, the protective shield would diminish, allowing increased levels of cosmic and solar radiation to reach Earth's surface. The effects would be far-reaching. Satellite systems, which power everything from navigation to communication, could fail, plunging us into a technological dark age. Electrical grids would be at risk of massive disruptions, causing blackouts on an unprecedented scale. On a biological level, heightened radiation exposure could increase cancer rates and harm ecosystems, disrupting food chains and agricultural systems. In a world reliant on technology and global interconnectivity, such a scenario would be nothing short of catastrophic. Beneath Earth's surface lies another ticking time bomb: supervolcanoes. These massive reservoirs of magma have the potential to unleash devastation on a global scale. The Yellowstone caldera, located in the United States, is one of the most infamous examples. While it has been dormant for thousands of years, its history is marked by eruptions of staggering magnitude. The last major eruption, approximately 640,000 years ago, ejected ash across vast swathes of North America, causing a volcanic winter that dramatically altered the climate. If Yellowstone were to erupt today, the consequences would be apocalyptic. Ash clouds could envelop the atmosphere, blocking sunlight and triggering a prolonged winter. Global temperatures would plummet, leading to crop failures and widespread famine. Entire regions would become uninhabitable, forcing mass migrations and creating geopolitical instability. Modern society, with its intricate supply chains and dense urban centers, is ill-equipped to handle such a scenario. The question is not if such an eruption will occur, but when, and whether we are prepared. Earth's cosmic environment is both a source of wonder and a lurking danger. The planet is constantly bombarded by meteoroids, most of which burn up harmlessly in the atmosphere. But history reminds us of the devastating potential of larger impacts. 66 million years ago, a massive asteroid struck the Yucatan Peninsula, triggering the extinction of the dinosaurs and reshaping the course of life on Earth. Today, the possibility of a similar event remains an ever-present threat. While advances in astronomy have allowed us to identify and track many near-Earth objects, the risk is far from eliminated. A large asteroid impact would release energy equivalent to millions of nuclear bombs, creating firestorms, tsunamis, and a global climate catastrophe. Efforts to develop planetary defense systems, such as deflecting asteroids with spacecraft, are underway but remain in their infancy. Humanity's ability to prevent such a disaster hinges on continued investment in space technology and international collaboration. Closer to home, Earth's climate presents its own existential risks. The delicate balance of greenhouse gases in the atmosphere regulates the planet's temperature, allowing life to thrive. But human activities, particularly the burning of fossil fuels, have disrupted this balance. Carbon dioxide levels are higher today than at any point in the last 800,000 years, driving global temperatures upward and triggering a cascade of environmental changes. One of the most alarming feedback loops involves methane, a potent greenhouse gas trapped beneath permafrost and in ocean sediments. As the planet warms, these methane reservoirs are at risk of release, accelerating climate change in a runaway effect. Rising sea levels threaten coastal cities, while extreme weather events, hurricanes, droughts, and wildfires become more frequent and severe. Ecosystems from coral reefs to rainforests face collapse, challenging humanity's ability to adapt. The consequences of inaction are clear: a world increasingly hostile to life as we know it. The oceans, covering more than 70% of Earth's surface, hold mysteries that could also pose threats. The mid-ocean ridges, where tectonic plates diverge, are sites of immense geological activity. Here, underwater volcanic eruptions can trigger tsunamis capable of devastating coastal regions. The Indian Ocean tsunami of 2004, caused by an undersea earthquake, killed over 230,000 people. But this pales in comparison to what could happen if a larger event were to occur. Underwater landslides, often triggered by seismic activity, are another overlooked danger. These landslides can displace massive amounts of water, generating tsunamis with little warning. Coastal populations, which continue to grow, are particularly vulnerable. The economic and humanitarian toll of such events would be staggering, underscoring the need for better monitoring and preparedness. Despite the magnitude of these threats, humanity is not powerless. Advances in science and technology provide tools to understand and mitigate risks. Seismologists monitor fault lines for early signs of earthquakes and volcanic activity. Climatologists model the impacts of greenhouse gas emissions, offering pathways to reduce our carbon footprint. Space agencies track asteroids and develop strategies for planetary defense. However, addressing these challenges requires global cooperation and a willingness to prioritize long-term survival over short-term gains. Investment in renewable energy, disaster preparedness, and scientific research is essential. Education and public awareness can also play a role, empowering individuals to advocate for policies that protect the planet. By acting proactively, we can reduce the likelihood of catastrophic events and improve our resilience when they occur. Earth's balance is a reminder of both its fragility and its strength. It is a system that has endured countless upheavals, yet remains capable of supporting life. Our challenge is to respect and preserve this balance, recognizing that our actions today will shape the planet's future. By understanding the forces that sustain Earth and preparing for the uncertainties ahead, we can ensure that humanity continues to thrive on this remarkable planet. In the end, the question is not just whether we can survive when Earth's balance breaks, but whether we can rise to the occasion, safeguarding our home for generations to come.